Hello, today we are here learning about the science behind density. Here we have a water molecule and an oil molecule. Oil is less dense than water and therefore floats on water. Water molecules have positive and negative charges that don't connect with oil molecules. I have my friend here to help me demonstrate the levels of density.
First, we will need a tall glass. Fill this glass with syrup, then the water, then the oil. Wait 15 minutes while the layers separate. We will drop different items in the glass to demonstrate the different layers of density. Due to the density, the items sit on different layers.
Please stand by.
Hello, I'm Lava Man. Have you ever seen a lava lamp before? It's really cool lamps that have wax and water inside. There's a light that heats up the wax and makes it rise. When it cools down, it comes back down and starts the cycle all over again.
One millennium later.
Thanks, Lava Man. Now it's time to make our own lava lamp.
We will need a glass, water, vegetable oil, food coloring, and Alka-Seltzer. First, pour the water, and then add the oil. Next, we add the food coloring. And then we break the Alka-Seltzer tablet in half and drop it in.
As you can see, the oil has changed colors, the food coloring, and the Alka-Seltzer is bubbling.
Why does the water start bubbling up?
Great question. The Alka-Seltzer is made out of two things, citric acid and baking soda. When you add it, it creates a chemical reaction and bubbles. That's just a few ways you can just learn density at home. We hope you enjoyed these projects and didn't make too much of a mess.
Pause. Man, it's always great seeing my twin scientist brother on TV. This is awesome. What a guy. And yeah, I can imagine it would get pretty messy if you used too many Alka-Seltzer tablets. If you use too many Alka-Seltzer tablets, can you imagine if they use 40,000 of them?
And now our grand finale. I'm going to dump 40,000 tablets of Alka-Seltzers to make the biggest lava lamp ever.
Wait, no.
No!
Hi, today we're gonna be making one of my favorite things ever, ice cream in a bag. We need 2 plastic bags, one big and one small. We combine half a cup of half and half, 1 tablespoon of sugar, half teaspoon of vanilla in the small bag, and then put your ice and salt into the big bag. Now place the small bag into the big bag. Shake the bag for 5 to 10 minutes. Now it's ice cream time. Very refreshing. Bye.
Hello, this is Tyler of the Media Lab, and I have a special experiment to show you that you can find here in your own home. For this experiment, you need a cup, a card, and a coin. Any coin. With the right amount of inertia and the right amount of force, the card gets flipped away, but the coin falls into the cup. And that is a nifty experiment that you could try at home. And that is, which means that creative equals science.
Hi everybody, I'm Elijah Cudwright Jones, PhD, and today we'll be talking about...
And I'm Mr. Wacky.
Can't you see I'm trying to teach the youth about magnetism here? I'm trying to tell you the absolute disgrace of the scientific community. Anyway, what is magnetism? Magnetism is a basic force of nature, right alongside gravity or electricity. It is a phenomenon that happens when electrons spin, resulting in attractive and repulsive forces in objects.
I have a magnet right here. Woo!
Thank you.
You're welcome.
Now, this magnet is made of iron, which is a few ferromagnetic metals that will exhibit enough magnetic properties for us to observe. It can also be made of cobalt, nickel, or steel.
Or gamma flabba.
No.
Thorium.
Every magnet has the two poles and they interact with each other in exactly two ways. Take a look at these circle ones. They have a light side, meaning south, and a red side, meaning north. Both opposites attract, but the same pole repel.
But you forgot about the giant magnet, this old planet.
You're actually right. Yeah, so the Earth also works the same way, having the two poles at either end, since the Earth's core is made of those same materials that makes a magnet. That's why when you use a compass, it always points north, because there's a little magnet in the compass too. See?
It's time for the experiment.
What? I didn't agree to an experiment. This is absolutely disrespectful. What is that?
It's a creature made of slime. Later.
It is interesting.
Check this out. This is a creature, it's a slime made with magnets. And if you pull the magnet here, you can make it say hello. And if you do it a certain way, you can even make it do a funny dance. Da-da-da-da-da-da. Or you could watch the slime slowly consume the magnet to the great abyss of nothingness. The magnet is its prey. Wow, fun, isn't it? Now I have to go. Hope Dr. Jones won't like to be kept waiting. You didn't see anything.
Wow, I saw that.
Where'd you go?
Ah! Don't worry about that. We were playing with the slime, this funny slime. Want to watch it consume a magnet?
Real original.
Huh, you can do better?
He probably made an ordinary slime by putting PVA glue, paint, baking soda, and eye drops into a bowl, then added iron filaments for magnetic properties.
How did you even know that?
They don't call me Eli the science guy for nothing.
Huh, that's a fact.
You don't forget it. So,
Well, in about 3 seconds.
So, in conclusion, opposites attract, likes repel, Earth is a giant magnet, and magnets are made of iron, cobalt, nickel, or steel, and can get their magnetic properties from electrons inside them spinning in the same direction. This isn't impossible. What did you do, you monster?
Rapid fire science.
Oh hey, you caught me having my favorite snack, Skittles and hot water. Some people may say it's a weird combo, but you know what I have to say about that. Take your Skittles and make a circle on your plate. Then take your cup of warm water and carefully pour it into the center of a circle until the Skittles are just barely under water.
Wow, that's amazing.
Crikey! Look at the hot water diffusing the color of the Skittles in the center of the water. As you can see, the hot water is causing the color to come right off of the Skittle. This is called diffusion. The water molecules and the color dye molecules are bouncing around randomly. The color dye molecules see that there's more room to them to spread and move across the plate. Oh look, we gotta go. I'm gonna have my snack now. Bye!
Diffuse the rainbow, taste the rainbow.
Random active science incoming!
Hey there, I'm Rich Nye, the science guy. Rich. Today, we're going to create a cloud right here in this bottle. That's right, clouds like in the air. Clouds are just gases that combine with small particles like dust. Let's go take a look what we need. Science rules. What you're going to need is a bottle. Any size will do. Rubbing alcohol, a bike pump, and a cork. For our safety, we're going to put on our lab coats and our eyeglasses to protect our eyes and clothes. So the first step is to coat the inside of the bottle with alcohol like so. We're going to twist it around a few times. Next, we're going to get our pump and a cork to fill the trap in the air inside the bottle. And we're going to pump it up until the bottle feels firm. Now just quickly remove the cork and watch what happens. Fire in the hole. The bottle quickly fills up with a cloud. By pumping in air, pressure and temperature rise inside the bottle, pulling it out with a cork and makes the hot rush outside, which shocks the alcohol molecules into compressing together in the air, which creates a cloud. Science rules.
Air pressure can be a very powerful force. We feel air pressure all the time without even feeling it. Wasn't I talking about magnetism earlier? How did I get here? I guess we'll try another air pressure experiment by crushing this can. So, you're gonna need gloves, safety goggles, a lab coat for protection, a bowl with ice water, some tongs, a heating surface, and of course, a soda can. Pour a small amount of water into the can. Heat the water up until it starts to steam. Use tongs to put the can in upside down. Whoa! That was intense, right? Want to know how that happened? It's simple. When you heat the can up, the pressure inside builds. When you put it in the water, the temperature drops and the pressure crushes the can. Crazy, right? No. No, 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 not again. Oh no! Why?
Science rules.
Random acts of ending this segment.
Looks like that's my cue to go. Hope you learned about air pressure. You can teach your friends about too. Just don't go too far with it. That's called peer pressure. Bye.
amazing.
So, in order to try this experiment at home, you will need a bottle with a neck, some thin mesh, cardstock, and a rubber band. Now, you have to fill your bottle up with water, and then you put the mesh on top like so. You keep the mesh taut on top of the bottle, like this. Put the rubber band around it. After you put the rubber band successfully on, you take one of the index cards or cardstock, place it on top, do it over the sink, flip it over, and as you can see, or maybe not, the water does not come out of the bottle.
Hi, this is Sydney. I have the MIUI special to show you my science experiment that you will see this at home. Those science materials you need: a plastic Ziploc bag, sharp colored pencils, and a water. As you can see, I fill up the plastic bag with water only to halfway. Now watch me, I stab the colored pencil through the bag. As you can see, the bag holds the colored pencil, it doesn't leak. Let's do that again. Sounds really cool. So this is creative equals science.
Alright guys, these are the materials you're gonna need to do this ice cube melting science experiment. Gonna need some ice cubes, a black trash bag, and a white trash bag. And if it's windy, to keep the trash bags from moving from the wind, I used tool set and a measuring tape to keep trash bags from moving from the wind. All right guys, they're all melted. You can hear it too, watch. It's all watery. But anyway, the black one melted faster. It's a fun science experiment. Can't wait to continue doing more. Love doing this type of science experiment. No limits, only possibilities.
It could happen at any moment. The ground shakes. You hear a rumble.
And then you grab your balls.
More on that in a bit. For now, let's talk about earthquakes. The Earth's top layer isn't one big piece. It's actually made up of separate chunks called tectonic plates, and they're always moving. When these plates get caught against one another, the pressure builds until they snap. A massive force is released, causing an earthquake. The intense shaking we feel is stronger at the center and weaker as it travels along the planet's surface. While some people believe that animals may be able to sense an earthquake before it hits, earthquakes don't have any real warning signs. That means it's up to us to make buildings that are as safe as possible during an earthquake. A seismic testing platform, also known as a shake table, is a massive machine that can hold an entire building and shake it like a real earthquake. You can build your own shake table at home with things you might have laying around.
For this experiment, you'll need 2 rubber bands, jingle, 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 4 rubber balls, 2 large hardcover books, and some sugar cubes. Put the 2 books together, wrap a rubber band around each corner of the book, connecting the 2 books together. You insert 4 rubber balls near each corner so that they're facing more towards the centers than the outside. What do you think, my son, that I built?
Silent talker.
I said, what do you think, my son, that I built?
Let's put some buildings on the shake table. We'll use sugar cubes today.
Good. Whatever you say, sugar. Thank goodness you didn't finish that first sentence, or else the FCC would be on us. How big are we talking here? Are we talking Empire State Building or the Wiz Khalifa?
The Burj Khalifa is the tallest building in the world, but it won't be that tall.
Is it time to shake it like a Polaroid picture yet?
Let's give it a shake.
Not you, you.
Now let's try building a short building.
I love Danny DeVito, especially when he's on that Always Sunny. Oh, what a show.
Let's see if a short building stands up any differently on our shake table. Now, what would you say we learned today?
I think we found out that sugar cubes are surprisingly durable.
Let's see that.
Yeah.
I mean, yeah, we already know this, but like, what about buildings and earthquakes?
Well, if I had to say anything, it'd be duck and cover during an earthquake. But also, don't build a skyscraper on a fault line, you little putz. They'll fall down like a pile of sugar cubes and you'll be screaming as the building comes and crushes you.
Even though we have no idea when the next earthquake will happen, there's a lot of great research being done by some very smart people like you who can help us stay prepared for the future.
Are you kidding me? Ah, I'm too old for this.
And I'm too young.
Buy my book!
Creative equals science. Creative equals science. Creative equals science.